afternoon to judges and friends. So sorry for the technical delay. We are Team 22 presenting on the intelligent maintenance system. Our problem statement is how might we help operations staff understand data trends so that they can conduct predictive maintenance instead of reacting to faults. The benefits of having a predictive maintenance system is so that you can use spare parts instead of relying on overhauling the whole unit, which is really a waste of resources. And also you reduce the need for scheduled maintenance. We want to shift from a just-in-case to a just-in-time kind of doctrine, whereby you only get maintenance only when you really need to. So you cut costs on manpower. And at the same time, you improve energy efficiency by means of having well-maintained equipment. To understand the product better, I'd like to introduce to you Min Yen, our operations manager from JTC, and Edward, the maintenance officer. As of now, Min Yen is really interested in having a so-called like a fast-free experience in her JTC complex. And she was told that this system might able to predict the faults before they even happen. So she could, using the user-friendly interface, she's quickly able to find out that lift B is not really working very well and might fail soon. So she quickly informs Edward by clicking on the SMS feature to inform him.
Oh no, I fix right now.
So thank you, Edward. So the next day, Edward faced a catastrophic failure in the lift. Oh no. So this time the system is able to identify a catastrophic failure and then look at the screen, so it takes some time. Or maybe it's not working. All right. And because of this, Edward is able to rush to the scene in the middle of the night and fix the lift before the office hours start the next day. Congratulations, Edward.
Once again, duty calls.
All right.
So now that the demo is done, so I'll be going through with you roughly how this thing works. So the core behind this is that we simply need a hardware with a precise accelerometer installed on it and a back end that receives all these data from the accelerometer. The implementation isn't difficult. It was just vanilla JavaScript and pure Arduino. This is doable, and the algorithm was developed in less than 3 hours. The algorithm that we use for this is fast Fourier transforms. I'm not sure if some of you know it. It's actually a very popular machine learning technique. So the kind of data that we have is sequential data. So in this case, this is actually a real data set taken from NASA's data repository on machine testing data. So they actually tested 4 machines to failure and recorded the accelerometer data on the machine throughout the whole lifespan. So
thank you. So I think that's 3 minutes.
Okay, yes.
Okay, but we will take questions.
By the way, thanks for the demo. I think it's a great demo. So how much have you spoken to any facilities manager in understanding the entire workflow right now in terms of building on top of what you have right now?
Our understanding is that currently, even though they have this kind of technology capabilities, but right now they do not have a smart system that is basically based on the accelerometer data triggers certain actions. I mean, this is not currently implemented, and in fact, it's an important concern in lifts. They break down in HDB flats and stuff. So it's actually widely usable. And not just in lifts, but pumps as well, because as long as it's machinery, it always has a resonance frequency, and you actually get the signature from the accelerometer data. Yeah.
The reason I ask is because I think once you can understand the entire workflow, I think you have a good starting point as in able to get this feedback loop from even the person on the ground back to whoever is managing the data.
Yeah, actually, mind if I share? Actually, this was part of our last slide. So just want to add that actually we plan for this to be a closed feedback loop, because whatever the engineer puts in, right, like for example the source of failure after they have gone down the sea, these nodes can be input back to the machine learning algorithm. So right now our algorithm will tell you whether this is a positive example or a negative example, meaning has it deviated very far from its original signature. But now we can actually identify what is the cause of failure if it matches a certain pattern that has been identified in the past. Yeah, so that is actually the intent of this system. It's supposed to be an intelligent end-to-end management system, for maintenance.
Did you get a chance to speak to any lift manufacturers about whether they have something like this inbuilt in the entire system?
Your question was regarding the fact that is this capability hardware currently available? The answer is yes, because they have safety standards. They will need to be able to have accelerometer data so that when anything happens, they can check back. But what we are offering, the value proposition here is the machine learning algorithm behind this. It's like a complementary suite that actually analyzes the data real time and serves it to your front end. Yeah, and we pull for data. Thank you.